In today's video, we're going to focus on derivatives of inverse trigonometric functions. So inverse sine, inverse cosine, inverse tan, inverse secant, inverse cosecant, and inverse cotangent. They belong to a group of functions, what we call transcendental functions. All right, transcendental functions are functions which cannot be given by any algebraic expression involving only their variables and constants. We've actually looked at derivatives of, or we've looked at transcendental functions in pre-cal A. When we looked at the derivatives of our trig functions, sine, cosine, tangent, cosecant, secant, and cotangent in pre-cal 12B. But today we're going to start with the derivative rules for inverse trig functions. First of all, what is an inverse trig function? Okay, well, this is the notation of an inverse trig function. Y equals inverse sine x, which can also be written as y equals arc sine x. So when you see arc sine, arc cos, arc tan, whatever the trig ratio, if it has arc in front of it, we're talking about an inverse trig ratio. Okay, what does that mean? It says y represents the angle whose sine ratio is equal to x. We are more likely to see that, or used to seeing it written like this. So when you see y equals inverse sine x, we can make it, rewrite that expression as sine y, the sine of angle y, is equal to x. And we can actually come up with a diagram to express this visually. All right? What that means, if there's no denominator written under the x, it's understood to be a 1. And we know that the sine trig ratio involves the opposite side over the hypotenuse. I know that I can express this using a right triangle. Okay? Y is the angle. I'll throw the angle down here in the bottom right. You could put it up here as well. Really doesn't matter. But that means that the opposite side, okay, so opposite of y is my x. The length of this side would be x, and the hypotenuse would be 1. So there's my hypotenuse, and there is my opposite side. Again, I knew the opposite was x and the hypotenuse was 1 because I was using the sine ratio. With a little work, I can figure out what the base of the triangle would equal. Just simply use Pythagorean theorem. A squared plus b squared equals c squared. So in this case, x squared plus, we'll call it b squared, equals 1 squared. Or b squared is going to equal 1 minus x squared. B would equal the square root of 1 minus x squared. So that would be the length of this side, 1 minus x squared under the square root. And that would be the adjacent side because it is next to y. So what we were able to do there is we were able to take this inverse trig ratio, or inverse trig function, and express it visually with this diagram here. Another example of a question involving an inverse trig function. All right, it says represent the inverse trig function z equals inverse secant 3x squared with a diagram. Let's start by doing that. Okay, so it'll start out exactly the same as that last question. Z is equal to the inverse secant of 3x squared, so that would mean the secant of z is equal to 3x squared. And I'll write over 1. Now remember, secant, we're dealing with the hypotenuse over the adjacent. Secant is the reciprocal of cosine. Fair enough. Let's make a little diagram. I'll draw my right triangle, and I can fill in some information. First of all, what is the angle I'm dealing with here? Well, the angle in this case is Z. I'll draw it in the bottom right. The hypotenuse would be 3x squared. And the adjacent side, now adjacent to z would be the base of the triangle, would be 1. All right, I can figure out this opposite side. So I have the hypotenuse and the adjacent. I can figure out the opposite side by simply using Pythagorean theorem. All right, a squared plus b squared equals c squared. So a squared plus 1 squared equals 3x squared squared. So this would be a squared plus 1 equals 9x to the fourth. A squared equals 9x to the fourth minus 1. A would equal the square root of 9x to the fourth minus 1. That would be my opposite side. The square root of 9x to the fourth minus 1. Okay, now I have all three sides of this triangle. Now I can solve the second question. It says evaluate the tangent of the inverse secant of 3x squared. Well, I know that this inverse trig function is actually equal to z. So I can simplify this expression or this equation over here to say y equals the tangent of z. All right. Z is the angle in this triangle down here. If I want to know the tangent of angle Z, I need to know the opposite and the adjacent sides. No problem. I got them. The opposite side is the square root of 9x to the fourth minus 1 over 1. Okay, that would simplify to the square root of 9x to the fourth minus 1. Okay, I am going to give you another question, and you can give it a run. I'll hide the solution. You can pause the video, give it a try, and then see how you made it. So here is the question. All right. It wants you to evaluate the cosine of the inverse cosecant of the square root of 5x. So I give you a little hint. I said let theta equals. Okay, so if theta equals this, see if you can follow, excuse me, the example from the previous page to get the answer. Okay, so pause the video, give that a try. This is the solution you should get. Okay, your final answer should be the square root of 5x minus 1 over the square root of 5x. And there's the work done in for you. So that is an example of an inverse trig function, or some problems involving inverse trig functions. Now we're going to look at the derivative rules for inverse trig functions. Recall that we already did derivatives of trig functions in pre-calculus 12b. So here are those rules, 6 rules, right? The derivative of sine u was cosine u times the derivative of u, and so on, all 6 rules. So we will see these come into play again as well. These are also transcendental functions, more importantly, or more specifically, derivatives of transcendentals. Today we're going to focus on the derivatives of inverse sine, inverse cosine, inverse tan. All right. Get rid of this. So differentiating inverse trig functions. It says let's start with finding the derivative. So what I'm going to actually do here is show you where these derivative rule, or the derivative for the inverse sine function comes from. I won't get into deriving all of them. I'll just do the sine function, and then I will show you what the rules are, and we'll go through some examples quickly. All right, so for Finding the derivative of arc sine x, or y equals inverse sine x. Remember, y equals inverse sine x is like saying the sine of angle y equals x. All right, now I could do the derivative of this using implicit differentiation. All right, remember this function is not in the form y equals, and I can't just divide both sides by sine. Like you can't have y equals x over sine. Right? It doesn't work like that. You need to have an argument. So these things stay attached. That's fine. I can do the derivative of sine y. Recall from pre-cal B, the derivative of sine u is cosine u. So in this case, my u value would be y, and the derivative of y would be dy over dx. So I would have the cosine of y times dy over dx equals the derivative of x would be 1. Now, if I want dy over dx by itself, okay, I can end up dividing both sides by cosine y, and this is what I will get. Now, I'm going to simplify this a little bit further. I'm going to specifically simplify the cosine y. How would I do that? Well, keep in mind that this this function right here represents a diagram over here. The angle is y, okay? The opposite side would be x, and the hypotenuse would be 1. The adjacent side, so this is the opposite, this is the hypotenuse, and the adjacent side would equal the square root of 1 minus x squared. How did I get that? A squared plus b squared equals c squared. X squared plus b squared would equal 1 squared, or 1. Subtract x squared from both sides, and I'd have b squared equals 1 minus x squared. If I want b, take the square root of both sides. Okay? The square root of 1 minus x squared is just that. So here is my adjacent side. Now, if I want to know the cosine of y, check this out. The cosine of y, I can use this diagram right over here to say that the cosine of angle y would be the adjacent side over the hypotenuse. Well, the adjacent would be the square root of 1 minus x squared divided by the hypotenuse would be 1. So this right here would become 1 over the square root of 1 minus x squared. So I'm just replacing that cosine y with this square root of 1 minus x squared divided by 1, which would simplify to the square root of 1 minus x squared. And that is where the derivative of the inverse sine function comes from. By a similar process, okay, we could do the same thing for arc cos, or the inverse cosine, and we would end up with negative 1 over the square root of 1 minus x squared. Or when we get into changing this argument from x to, we'll say, something called u, we have to remember to multiply by the derivative of u. So, in short, there is your derivative for an inverse sine function. There is your derivative rule for an inverse cosine function. Here are the other 4, okay? So arc sine, that just means inverse sine u. So the derivative of inverse sine u is equal to 1 over the square root of 1 minus u squared times du. Okay? And here are the others. Now we will practice, or we will try and apply these rules. So you would be required at university to know these 6 along with your 6 derivative rules for trig functions as well. So don't be scared to study those and commit those to memory. Okay, a couple of examples. All right, in this first example, what is our u value? 2x squared. what is the derivative of u? 4x to the first. Now, this is an inverse cosine function. So the derivative of an inverse cosine function, if you look back to your rules, it's -1 divided by the square root of 1 minus u squared. Well, my u value is 2x squared times the derivative of u, which is 4x. When I simplify this, I'm left with -4x over the square root of 1 minus 2x squared times 2x squared would be 4x to the 4th. That is your answer. Again, all I was doing is using this rule right here. -1 over 1 minus 2x squared to the power of 2 times 4x. Okay, arctan 3x, next example. My u value is 3x. My du is equal to 3. Arctan, or inverse tan, looks like this. It's a 1 over 1 plus u squared. Well, my u value is 3x. And then I multiply by the derivative of u, which is 3. Multiplying the tops, 1 times 3 is 3. 1 plus 3x times 3x would be 9x squared. That is my final answer. Okay, for this one, my u value is equal to x to the 1/2, or root x. The derivative of x to the 1/2 would be 1/2 x to the -1/2, which I will call 1 over 2 root x. Okay, we've done that one several times, so if there's any confusion with that, you can fire a question in Teams, but just a simple little power rule. Now, the derivative of inverse sine looks like this. It's 1 over the square root of 1 minus u squared times du. All right, well, what is my u value? It's a root x. What's my du value? It's 1 over 2 root x. Multiplying the top by the top, I'd get 1 times 1. Bottom by bottom, I'm going to have 2 root x times 1 minus, well, root x times root x would be x. And that is under the square root. Now, you can leave it like that, but a lot of times we might bring the 2 root x in under that square root. So it would look like this. It'd be a square root, and then in order to get that 2 root x in there, I'd have to square it, okay? It would have to be a 4x times 1 minus x. Okay, so that 2 root x, it went in under the square root. There must have been two root x's in there, so 2 root x times 2 root x would give me 4x. Okay, so in order to get it back under the square root, I have to square it. And that is your final answer. Or you could call it 1 over 4x minus 4x squared if I multiply that out. Next example. 2 arc cos 2x. Now that constant 2 will stay here, and I will multiply that by the derivative of arc cos 2x. Keep in mind that your u value in this case would be 2x. The du is just a 2. For arc cos, the rule is -1 over the square root of 1 minus u squared. Well, my u value is 2x. My du value would be 2. That would be the derivative of this first part right here, 2 arc cos 2x. The derivative of my second part, well, think of this as 1 minus 4x squared to the 1/2, which requires a chain rule. That would be 1/2 times 1 minus 4x squared to the negative 1/2 times the derivative of what's inside the brackets. That would give me a negative 8x. Okay, the derivative of 1 would be 0. The derivative of negative 4x squared would be negative 8x. Now I'll clean this up. 2 times negative 1 times 2 gives me negative 4 over 1 minus 2x times 2x is 4x squared. Here, I'm going to get a negative 8x divided by 2 gives me a negative 4x. Times a positive 1 would give me a negative 4x. And then I'm going to send this whole thing to the bottom. Why? Because it has a negative exponent. So on the bottom, it would become 1 minus 4x squared to the positive 1/2, which is like saying 1 minus 4x squared under the square root. Simplifying, because they have a common denominator, I will simply subtract the tops. It gives me negative 4 minus 4x over the square root of 1 minus 4x squared. Now you could factor in a negative 1 if you wanted from the numerator and call it negative 1 times 4 plus 4x, all the same to me. Last one, okay? This last one has a product rule in it. This says x times the inverse tangent, that negative is hard to see here, of root x. So in order to do a product rule, remember the product rule is the derivative of the first, 1, the derivative of x would be 1, times the second. The second function in this case is the inverse tangent of root x, plus x, the first, times the derivative of the second. Now remember, when you're doing the derivative of inverse tan, helps to know our u value and our du value, 1 over 2 root x. Okay, see above for that. But this would become the derivative of inverse tan is 1 over 1 plus u squared. So this would say root x squared. And then I would multiply that by, excuse me, 1 over 2 root x. And I'll close this bracket, and then I will simplify my answer. Okay, this first term doesn't really simplify. 1 times the inverse tangent of x is the inverse tangent of root x, not x. This, however, will simplify. I will end up with x times 1 is x, and on the bottom I'd have a 2 root x times a 1 plus x. All right, root x times root x would give me this x. Now, don't forget that when you have an x divided by a root x, that's like saying x to the first divided by x to the 1/2, which would equal, okay, 1 over 1 would be 2 over 2 minus 1 over 2. That would simplify to x to the 1/2. So this final answer would actually look like this. F prime x equals so it would equal, excuse me, it froze up on me, so I had to reset, the inverse tangent of root x plus the square root of x over 2 times 1 plus x, or 2 plus 2x. Again, where did that root x come from? Right over here. X divided by root x is equal to root x, or x to the 1/2. That's your final answer. All right, there are some questions from the text that you can try. They are on page 339. You can do 1, 2, 4, and 6, please and thank you.